So you tell me what you would like me to start with, and then we'll go over the rest. So what would you like me to start with? Any preference, anything? You're muted. Carly, you're muted.
Me personally, I think anything that was on the previous test.
Okay.
Because I think I have a really good understanding of like the first and second test. But the last test, obviously, I need improvement. So anything from that.
Okay. So what I was going to say. So, Kaylee, do you have any preferences?
Ma'am, honestly, same thing. This last test is really just what got me. I'm pretty good with the first and second one.
Okay, so let's go over that then. Good. So, okay, so Elena is here. Good. So we're going to start then from the very beginning with question 1. So we have 2x to the 4th multiplied by 5x to the 3rd, then times x. We have to multiply the factors first, so we get x, and we get 10, and then we copy x because we are multiplying exponential notations. Copy the base and add the exponents. 4 plus 3 is 7, plus 1 is 8. The next one, stop me if you have any questions, right? I don't want to just move on through. Do you have any questions? Elena, do you have any questions that you would like me to start with?
I'm not sure if I'm supposed to unmute or if my audio is good. I'm in a semi-public place right now. But no, I don't have any questions at the moment.
Okay, so you can stop me. Anybody stop. Nadi, do you have any questions right away? You're muted.
No, I don't have anything specific.
Okay, so we're going through the previous test for now. I have till 7 o'clock when I start the class. That's why I wanted to answer all your questions. So get ready. Any questions that you may have. Okay, so here we have 1, 2, 3 factors. All these 3 factors have to be raised to the 4th power. Negative 1 to the 4th power is 1. 2 to the 4th power is 16. X to the 3rd to the 4th power, we copy the base, multiply the exponents. Again, stop me anytime, okay? If you have any questions. So negative 10 xy to 0. Any number raised to 0 is 1, except 0 raised to 0 is not 1. So in this particular case, we would write that y raised to 0 is 1, assuming that y is not 0. So then the answer is simply negative 10x. You cannot transfer this power over other factors. This power is attached to y alone. If you have parentheses, it's a different story. But right now, only y has this power. Here is a different story. All these factors have this power. Okay. The next problem is negative 4x to negative 1. You cannot transfer negative 1 over anything else. This is one factor, this is another factor, this is the third. Only the third factor has power negative 1. So negative 4 cannot be moved anywhere. But x to negative 1 is 1 over x because a to negative n is 1 over a to the nth power. The next one is 1 over 4x to negative 2. So if I swap these two, I have a to the nth equals 1 over a to negative n. And this is the situation I have. I have 1 over a base raised to a negative exponent. So it will go up, but you cannot touch 1/4. 1/4 does not have this power. Only x has this power. So the answer is x squared over 4. Because if an exponential notation has a negative power and it's in the denominator, it can be moved to the numerator with a positive exponent. Only if it has negative power and it's here in the denominator. But 1 has power 1. 4 has power 1. The 1/4 cannot be changed, cannot be transferred, moved anywhere. Anyone, any questions?
I had a question. I don't know if you're able to see the chat, but I put it in the chat. It's from actually the test 2, and I just wanted to go over the inequality problem.
Okay, so let's stop for a second and look at this problem. So we have negative 3x minus 1 greater than 3x plus 12. Good. So I move 3x to this side and I have negative 6x. I move negative 1 to this side and I have 13. And I divide both sides by negative 6, which means I have to, I am forced to. Every time I multiply or divide both sides of an inequality by a negative number, I have to switch the inequality symbol, and I have negative 13 over 6, and the interval notation is negative infinity, negative 13/6, parenthesis at negative infinity and infinity always, parenthesis at negative 13 over 6 because there is no equal symbol. Is this okay?
Yes, thank you.
Thank you. If you have other questions, you can always stop me. Good. The next in line, we had p minus p to the third plus 2 plus 6 minus 2p squared plus p to the third. We always put everything in descending order. We start with power 3, but these two are gone. I continue with power 2. And then I continue with power 1. And then I continue with no power. And this is it. The next one was 4t minus t minus 3. So this is 4t minus t, but I have to distribute to both terms. I cannot pick and choose. I cannot distribute negative 1 to only one term and forget about the other. So therefore, the simplified form is 3t plus 3. The next thing is 2x plus 1 to the second power. And as I mentioned, a binomial squared is a trinomial. So you cannot simply say, oh, I'm going to square 2x and I'm going to square 1. That's not allowed. It's not possible. It's wrong. First term squared plus 2 times the first times the second plus the second term squared. Again, first term squared plus, because it's plus, 2 times 2x times 1 is 4x plus the second term squared. The next problem is y to the third minus 6y squared plus y divided by y. You cannot simplify terms. You can only simplify factors. One possibility is to factor out y, and then you will be able to simplify it. But now I have to be careful because I have 3 terms here and I have to have 3 terms left in parentheses. And I have y squared minus 6y and plus 1. Double check. Y times y squared, y times negative 6y, and y times 1. So now the simplified form is y squared minus 6y plus 1. You can always, because it's one term in the denominator, one term, you can also separate the fractions into 3 fractions. Why 3? Because I have 3 terms at the top, and you will get the same answer. You will be able to write y to the third over y minus 6y squared over y plus y over y. This is allowed. If I have here plus 3, you will never be able to do that. You're not allowed to. But if it's only one term, that is allowed. You can separate it in as many fractions as needed. In this case, I have 3 terms at the top. I will simplify or separate into 3 fractions. So then the same thing. I get this over this, copy the base, subtract the exponents. This over this, copy the base, subtract the exponents, and this is 1. Of course, the correct restriction here should be y not equal 0. So what I'm saying here is that this expression does not simplify to this unless y is never 0. And this is what I call a restriction on the variable. For this to exist, y cannot be 0. And if y is not 0, then this expression simplifies to this. Any questions? Okay. I'm going to send these notes to you. You don't have to take notes right now. I'm going to send you the video and also the PDF file to everybody. Okay.
Thank you. Sorry, I wanted to mention I put a scientific notation one in there. I got really confused during the scientific notation part on the test.
Yes. Okay. So let's look at that one and then we'll continue. So 7 times 10 to negative 10 multiplied by 3 times 10 to the second power. Perfect. 7 times 3 is 21. Copy the base. Negative 10 plus 2 is negative 8. Scientific notation requires one number, not 0, one digit, whatever, times a power of 10, which can be positive or negative, whatever power of 10. So scientific notation requires one digit, not 2, one digit, the decimal point. This number cannot be 0. Anything else you want from the number multiplied by a power of 10, so 10 to a power, and this power can be positive or negative. So this is okay, but this is not scientific notation because the decimal point is here, and I cannot have 2 digits. This is 1 digit only. So therefore, I am moving the decimal digit 1 spot to the left. So I'm changing 21 into 2.1. So I have to multiply by 10 to the first power. But I have to multiply by 10 to negative 8. When I multiply these two, copy the base, add the exponents. So then I get the final answer to be 2.1 times 10 to negative 7. And you can say, why on earth will I need this? The reason is the following. It's for the use of the graphing calculator. And I have the calculator in the background. So when we use the calculator and we get a number like this, for example, what does this mean? This is the scientific notation. It means 2.0 la 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 times 10 to power 33. We have to be able to understand what this means. What about this? 1.22 e negative 7. What does this mean? It means 1.22 times 10 to negative 7. So that's the reason why we need to be able to read and convert scientific notation into decimal numbers and decimal numbers into scientific notation for this reason. Okay, next problem, where are we? Yes. So there is a rule that is a divided by b raised to negative n. This is the same with b over a raised to the nth power. So the next example is negative 3x to negative 2, which will change into negative x over 3, everything to the second power based on this rule. But now I have negative 1 to raise to the second power, x to raise to the second power, and 3 raised to the second power, and I get x squared over 9. Because when I raise negative 1 to the second power, I get 1. Any number raised to an even power is always positive unless there is a minus in front. So any number, I'm on page 4, any number, positive or negative, raised to an even number, this is always positive. If the power is 2, 4, 6, etc., etc., the answer must be positive, unless there is a minus in front, which is a different story. Okay, then we are asked to simplify 7x squared x plus 3 minus 2x x squared minus 1. You have to distribute, and you have two terms. And you distribute one factor. You have to have two terms, not more. So 7x squared times x is 7x cubed. 7x squared times 3 is 21x squared. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 1 is positive 2x. We have to combine like terms and present everything in descending order. 7 apples minus 2 apples is 5 apples. 21 has nothing to do with 2x, so 21x squared is alone, and then plus 2x. I'm assuming you're going to stop me if you have questions. So 1 minus 2, y squared plus 1 plus 1. Y squared plus y plus 1. Y has to be distributed to all three. Y cubed plus y squared plus y. Negative 2 has to be distributed to all. Negative 2y squared, negative 2y, and minus 2. Combine like terms. Always present everything in descending order. These two, negative y squared. These two, negative y, and negative 2. And this is it. Then 4, x minus 1 squared. You cannot distribute before you square. 4, first term squared, minus 2 times the first times the second, plus the second term squared. Now I can distribute. 4x squared minus 8x plus 4. Okay, we already did that scientific notation. There is another one, which is 4 times x to the 6th over 2 times 10 to the negative 3. 4 divided by 2 is 2. Copy the base, subtract the exponents, and that's the rule. 6 minus negative 3. Then we want to evaluate, which is 2x squared minus x plus 3, for x equals negative 2. 2, negative 2 squared minus negative 2 and plus 3. First we square. I get 4 because any number I square, because the power is even, I always get a positive number. Negative 2 squared is 4. 4 times 2 is 8. Negative times negative is positive, and plus 3, so that is 13. Then we have a question on factoring. So we have negative 12 minus x plus x squared. First, we rearrange in descending order. And then we realize that here, the sum of the two numbers I need is negative 1. This is always the sum. And this is always the product. So the same numbers, I'm sorry, when I multiply them, I get negative 12, and the sum is negative 1. So I know it's negative 4 and positive 3. Negative 4 times 3 is indeed negative 12. Negative 4 plus 3 is indeed negative 1. So the answer would be x minus 4 and x plus 3. And you can always go back and check by distributing to make sure you don't lose points. Okay, the next one, x squared minus 4x. You must factor out x. And you have x minus 4 and there is nothing else. You can check. X times x is x squared. X times negative 4 is negative 4x. 4 minus x squared. Always in descending order first. That's mandatory. If there is a negative leading coefficient, you have to factor it out. The leading coefficient, if it's negative 1, you have to factor that out. And then this is the difference of squares. A very important formula. So this is x minus 2 and x plus 2. The next one is x squared minus 4x plus 4, which I always teach my students in the following way. What do you have to square to get x squared? Well, it's x. What do you square to get 4? 2. Since this symbol is negative, I put negative and I square, because a binomial squared is a trinomial. But I haven't checked the middle term. The middle term here is 2 times the first times the second. 2 times x is negative 4x. Yes, that's correct. So first you look at the first term and the last term. You conclude x squared will be x squared and negative 2 squared would be 4. But I have to check the middle term. I didn't even check the middle term. I only based my conjecture here on the first term and the last term. That's not good enough. What if this one is 5x? So this is wrong. So then I check the middle term. Minus 2 times the first times the second. If that's negative 4x, these are correct. This is this, and this is this. But I have to check. That is a mandatory step. Since I'm sending this to you.
Question
Yes.
to clarify.
Yes, yes.
So basically on the test, you said it's a mandatory step, so we're supposed to show it, check
No.
by the side?
No.
Whatever we do?
No.
Okay.
Mandatory step in the thinking process. But I'm okay if you don't show
Okay.
that. Good. Good. So the last two are formulas, which are extremely important. There is no example in there. There is nothing difficult, but you have to remember these formulas. So this is the sum of cubes, and this will be the difference of cubes. So it's basically the same formula. And this factors into a binomial and a trinomial. The binomial is exactly what you see here, either a plus b, or of course a minus b. If this is a cubed plus b cubed, this is a plus b. If this is minus, this is minus. Now, plus plus minus in the middle, minus minus plus in the middle. That's the sequence of signs. So if I factor the sum, I have the sum in the binomial, but the difference in the trinomial. If I factor the difference of cubes, I have the difference in the binomial, but the sum in the trinomial. This piece is kind of similar, but not quite with this idea, with this formula. Not quite. Similar. The first term squared. The first term squared, which is always positive. But this one is not 2 times this, but just this times this. Okay? So, a cubed plus b cubed is a plus b times a squared minus ab plus b squared. But a cubed minus b cubed is a minus b, a squared plus ab plus b squared. Very important formulas. Okay, then we were asked to factor. So 9x cubed minus 6x squared plus x. Descending order first. Greatest common factor next. Always. Always factor out the greatest common factor. If this were negative, I would have factored out negative x. I refuse to work with negative leading coefficients, and so should you. Good. So then let's see, 9x squared minus 6x plus 1. Again, I will say, this appears to be 3x minus 1. How come? Well, the 3x squared is 9x squared. The negative 1 squared is positive, but squared. But the middle term here is 2 times the first times the second. If I don't have negative 6x here, this is incorrect. Oh, I do have negative 6x. So 3x minus 1 squared is indeed this. The first term squared minus 2 times the first times the second plus the second term squared. So this is okay. Now the next one, I see 4 terms. Every time I see 4 terms, I think in terms of factoring by grouping. In other situations too, but especially with 4 terms. Good. I look at the first 2 terms and I see x squared is a common factor. I refuse to look at the other 2. If I cannot get x minus 1 as the common factor, I cannot continue. I will write it first. Then I have to find a sign and a factor. Negative 1. Negative 1 times x, negative 1 times negative 1. Now I am able to continue because this is the common factor that comes out. And what is left? X squared and negative 1 are left. But this is the difference of squares. So I have x minus 1, which is this factor. And now I factor this into x minus 1 and x plus 1. I realize that these two can be rewritten as x minus 1 squared. And times x plus 1. And this is completely factored. Completely factored. The next one. 12y squared plus 32y minus 35. Okay. Now, again, this is the most difficult type of trinomial to factor because of these large numbers. However, let me move this page away. However, the thinking process is the same. The product and the sum of the numbers I need. The sum never changes. It's always the coefficient of the middle term, always. The product, however, if this is not 1, we had a situation a few minutes ago in which the leading coefficient is 1. So I did not have to incorporate this number in the product because 1 times negative 12 is negative 12. Well, in this case, I have no choice. I have to incorporate 12 as the product with negative 35. When I calculate this product, I get a huge number. Difficult to handle. Instead, I'm going to do this. 12 is 2 squared times 3. 35 is 5 times 7. I'm going to write here the factors. Of course, negative, because 12 times negative 35 will be a negative number. But I will have 2 squared times 3 times 5 times 7. Why I'm doing this is because I need to find a number that is positive and the number that is negative. When I add them, I get 32. And when I multiply them, I get this huge number, whatever that is. What is this number? I don't know how to handle such a number. 420. Who cares? So this is 420. I put it in prime factorization because it's easier for me to find out what I need. So, and I'm thinking, okay, how do I combine these into two numbers, one positive and one negative, so that I can handle the 32? So I try combinations, 4 times 3 and 5 times 7. It's not going to work. 3 times 5, 15 and 28. It's not going to work because I cannot get 32. And after I spend a little bit of time, I realize that the 42 and the 10 is what I need. A 2 with a 5, which is a 10, 2 and 3 and 7, which will give us the 42. Yes, I have to agree that this is, as I said, the most difficult one because it involves multiplying two huge numbers. I mean, big numbers. Okay, so then what follows now? I have to replace the middle term by these numbers, these terms if you want. 42y minus 10y. 42y minus 10y will give us 32y. We're not changing the problem. But why am I doing this? Because I want to use factoring by grouping. So from the first two, I factor out 6y. What is left? I have a 2y and plus 7. I do not look here. I refuse to look because I may come up with something that is wrong. Who knows? I copy it first. I know it's there. How do I know? Because I found two numbers whose sum is 32 and whose product is this whole thing. This factor has to come out from both. It's mandatory. I don't look because who knows? Now I do. Oh, okay, never mind. -5. -5 times this is this, -5 times 7 is that. But now I found my common factor, and I'm done with 6y minus 5. Is it true? I don't need anyone to tell me yes or no. I'll multiply myself. This times this is 12y squared. This times this is -10y plus 42y is 32y. 7 times -5 is -35. I know it's done. The equations. So we have n squared equals n plus 6. It's quadratic. I have to set it equal to 0. I can't solve. So in order to solve it, I have to move the terms from right to left. And now I will factor. Luckily, the leading coefficient is 1. The product is -6. The sum is -1. I know n minus 3 and n plus 2. And I'm done. N equals 3, n equals -2. But it's quadratic. I have to set it equal to 0. And when I move terms from one side to the other, I only change their sign. The next one requires distributing the factors in there. So x minus 2 and x minus 3 equals 6. It's quadratic. I have to set it equal to 0. But I have to distribute here. So I have x squared minus 3x minus 2x plus 6, and I move 6 to the other side. Oh, nice. So then I have x squared minus 5x equals 0. I factored out x, and I get two options. X can be 0, x can be 5. Any questions? Okay. Then the word problems. We had age of t equals -16t squared plus 40t. The height of the rocket in feet and t in seconds. What equation should you solve when it hits the ground? Okay, age of t equals 0. Hits the ground. This is the equation. What equation should you solve to find when the rocket is 25 feet above the ground? Okay, age of t equals 25. That's it. Of course, you have to put this in here and this in here. Same thing. This is acceptable. This is acceptable. If you want to write it as -16t squared plus 40t equals 0, that's fine. This is acceptable. And -16t squared plus 40t equals 25. This is acceptable as well. Retaining wall has 15 square feet. So this area is 15 square feet. The height of the wall is 2 feet less than the length. The height is 2 feet less than the length. It's the length minus 2 feet. Okay? What equation should you solve to find the dimensions? Okay, so the area is 15, but the area is 15 square feet. The area is length times width. I'm sorry, I should write height. Because I used height. It's length times width, but since I mentioned height, I use height. Let me use height. To be consistent. Same thing, but to be consistent. So 15 equals length times height. But the height is L minus 2. I have to replace h by L minus 2, and this is 15. And this is it. And divide, as I mentioned, division 2x to the third minus 5x squared plus 7x minus 15, everything divided by x squared. the only thing we can do is separate into 1, 2, 3, 4 fractions. 2x to the third over x squared minus 5x squared over x squared plus 7x over x squared minus 15 over x squared, and simplify each and every one of them as much as possible. So this one is 2x, this one is minus 5, this one is positive 7 over x, and this one stays as is, nobody can touch it. Any questions? Any questions?
Okay, I have a question. Can we review, it was like the 12y squared plus 32. I think it was only page 7. Yeah, and y minus 35. So it's 32y minus 35. We already did it, but that one is really confusing me.
Well, when you watch those videos, it will be very clear. So because the leading coefficient is not 1, this is the product. So this happens because the numbers are, the number that I'm getting when I multiply is 420, which is a large number, right? So the options here, so we have 2 squared and 3 and 5 and 7. So you just have to try to group them. So I'm looking for two numbers, one positive and one negative, so that I obtain, when I add them, I obtain 32. So what are the options? As I mentioned, 12 and 35 doesn't work. Another option, 4 and 7, 28 and 15. 28 minus 15 is not 32. What other possibilities? So, or you can simply write it better like this. So I realized that my only option is a 6 with a 7 and these two. So this one will be a 42 and this one will be a 10. And this is my only option. The 42 minus 10. 42 minus 10 will be 32. Only because this number was 420. Go ahead.
So you're adding the factors, you're simplifying and then adding the factors together.
I'm not simplifying them. I presented the prime factorization of the number.
Okay.
So
And
the
then
prime
add them back
factorization of the number enables me, or helps me find the two numbers I need.
Okay. I see. Because then you add, okay, I see. I understand.
Yes. So I'm trying all sorts of combinations. So I tried 12 and 35, but 12 and 35 will not give me a 32 when I subtract them. Then I tried 28 and 15. That will not work. I will not get a 32. So then my next option is 6 and 7, which is a 42, and 2 and 5, which is a 10. And then 42 minus 10 is indeed 32. Is that better? Any other questions from past, present, and future that we are studying?
Here's a question. This is kind of in general, but what formulas do you think are most important for the final?
Just everything that we studied in the class. I can't narrow it down in any way, shape, or form. Not because I don't want to, it's because everything is basic. I'm not saying it's too simple. No, I'm saying is the basis better, the basis of the next classes. So I can say, forget about the quadratic formula, or forget about the area of a circle, or forget about the area of a rectangle, because everything is needed for the next course. It's a very good question. really.
Okay, that makes sense. I just wanted to clarify to see if there's any like things I should really focus on. But if you're saying it's mostly everything, I can work with that.
It's really everything. I can't really, as you know, with math is you can't get to the roof if the foundation is weak.
Yeah, that makes sense.
Anything else that you would like us to go over? Anything else, please? And I'm sorry that that students who
I do have one more.
yes, yes.
Okay, so how do we know when it's time to factor? How do we know that it's one that we group and then one that we do the ax squared is bx squared formula? Like how you just did the factorization. Like how do we know when we do form that way and when it's time to factor it and group it?
Number one is practice. And you mean, oh, I see what you mean. You're basically asking about this trinomial. Are you basically asking about this trinomial?
Yeah, like that one. Like how do we know like that we can't group it to factor it and we have to do it that way?
It's because there is no other formula for this trinomial. You cannot use a special product because this is not a perfect square. This is not a perfect square. It's a very good question. It's a very good question, actually. So how did I know here to do this? Because I see that the first term is a perfect square and the last term is a perfect square, and I assumed this, but not before I checked the middle term. Because if the middle term is 5x, this is wrong.
Right.
But here, I did not even discuss that option. Thank you. It's a very good question. Why here I said, oh, it must be this. But here I didn't. Because 12i squared is not a perfect square. There is nothing that I can square to get this. And finally, and very, very important, this is negative. There is no number that I square to get a negative 35. So there is no reason for me to even discuss this option.
Okay.
It's a very good question. Good. Anything? Yes. Anything else?
I have another question.
Yes.
So, can you show a scenario in which it's prime?
Yes. It's a sum of squares, which cannot be factored.
So basically, when it doesn't factor out, that means it's prime.
Yes. X squared plus x plus 1 is prime. No, you cannot factor in any way, shape, or form. For example, x squared minus 4 is x plus 2x minus 2. Because it's a difference of squares, but the sum of squares is prime.
That's very interesting. I was always curious about the sum of squares.
Actually, there is a way, but we say when we talk about factoring or completely factor, what we really talk about is using integers. But yes, x squared plus 4 can be factored as x plus 2i and x minus 2i. But this is not using integers. So that's why we call it prime. But it can be factored using imaginary numbers. But we don't really care about that at this point. But yes, it is factorable, but not using integers. And when we say completely factor, we don't really mean this. No, we do not.
Okay, that makes sense.
Good. Anything else? So this is a class that is a non-credit class. An A, a B, or a C in this class are all the same. However, for your major, which I'm not an advisor, so I can't say, and I don't even look at students' majors. I never pried into anybody's. Can I stop the recording now or not yet? Do you have anything else for me?
No, that's I'm finished.